All right, so we can graph and solve these equations too. We're still in between the absolute value equations and piecewise functions, so we're kind of in between. So first things first, you're going to see this very complex equation. But when we go to solve them, we give them something like an f of x or a g of x or an h of x or a q of x or a p of x or whatever. Just usually something other than a plain old y. So we're going to take this little piece and call it something, and then we're going to take this little piece and call it something else. Okay, so what we do is we're going to let it look like this. Okay, we're going to give it f of x this, just like I said, and g of x this. Okay, and we're not going to solve them by paper because this is just crazy. So, but we are going to, I'm going to show you how to put these into your calculator so that we can graph them, okay? Because it is kind of important that we can do a graph on these, okay? So, going to graph these is fairly simple. We take our calculator, and I'm going to take it, and we're going to clear that out. I'm going to clear that. So our first graph is going to be blue, and the second one is red. It's a bummer, but that's the way my calculator's set up. We can change the colors later, but really we just got to get through this. So f of x is just a fancy y, okay? So we're going to put this into the calculator. So we go back down to the word, remember, math. We're going to go to math, num, ab. We're going to get the absolute value, and you're going to have x plus 2, and we're still inside the absolute value until you arrow yourself out of it. Okay, then we have a minus 3 that's on the outside of the absolute value. So I don't know if you click it. So it looks like that. Okay, and then after we do that, we're going to press graph, just so you can see what it looks like. We have this vector. Okay, now we're going to put both of them on the graph at the same time, just so I can show you what it looks like. You don't have to graph them at the same time. What I normally do is press second function, and then I have my table, and I plot this, okay? And then it doesn't give me a set of domain to use, so I just get to make them until they cross, okay? So then I would draw this out, all right? I'm going to show you after what it looks like when you put them all on the same, but we're going to go 0, -1, 1, 0, 2, 1, 3, 1, 2, 4 up 1, 2, 3, and I'm going to get -1, -2, -2, -1, 2, 3, -4. We got -4, 1. I'm going to get all those 3. Go to the 3 up 1, 2, -2, down 1, 2, 3, over to the -3, down 1, 2, over to the -4, oops, down 1, my bad. And let me just check 1, 0, yeah. So, and then we can keep going. So we have this vector, okay? We could keep going if we want, but that's our vector, okay? So now we can check our graph, and that's what it looks like. And it looks just like my paper. All right, so now I'm going to go back to y, and I'm going to clear that out just because I don't like when I put 2. And we talked about this in class before. Now this next one doesn't have any absolute values. It's just going to be a line, and it's going to look like that. Okay, and then I'm going to press second function table, and I'm going to take some of those points and I'm going to put them into on the screen. So I have a 0 up 1, and I have a -2, 0. I have a 2, 2, so over to the 2 up 1, 2. I have over to the 4, up 1, 2, 3. Oh, I got a common point right there. I'm going to jot that down. I got a 4, 3 right there, a match. And it looks like maybe I might have this one as a match also. So I go over to 4, -1. Yep, I have a -4, 1. So I got my straight line doing that. Okay. All right. And then I'm going to show you. So remember, it looked like that before. Let me see. Now I'm going to put the vector one back in. So I'm going to go to Y. I'm going to arrow down to the next one like that. So the next thing's flashing, and I'm going to re-put in math, ab, and I'm going to put in the x plus 2 arrow out minus 3 graph. And now my two graphs overlap. Okay. And as you can see, they overlap in 2 spots. This is why I don't like the tables, because now the tables have 3 parts and you have to look where they meet. But if you notice, if I can get it to work, the 4, okay, let's see. See the 4? This is 4, 3, 3, and the 4 column. And also at the very, very top of it, very, very top where it's black, it says 4, -1, -1. The -1 is in the blue and in the red. So that all matches. That's how we know where they meet. Okay, so it says, where does f of x equal g of x? They equal each other at the points -4, -1. That's a negative. And they meet also at 4, 3. So they meet when x equals 4 and when x equals -4. That's mainly what they're asking, because the x's are what we're talking about here. So that's the most important part. So that's what I wanted to show you there. So I'm going to flip my page. Okay, so now we're back to the where we used the other day, Cartesian planes. And so the first thing we're going to do is we're going to split the path again. Remember, we're going to make this into maybe an f of x and maybe make this one into g of x or a p of x. So if you notice here, we have this and here we have this. So explaining this front part, not this negative, but just this front part. Remember, we talked about if it's in the absolute value and you see a -3, we don't actually shift it this way. We shift it positive because we have to do the opposite. You see this +4? That does mean 4 jumps up. So this vector is going to be somewhere up, but it's going to be facing downward. Okay, so our f of x, since it's negative, our vector is not going to be like this. Our vector is going to be like that. And here, this is a positive vector, so absolute value. So this is going to be shifted down 5 units, and that's just in it. So that right there is going to be like down here, making a vector. All right, so what we're going to do is we're going to plug them into the calculator. So I'm going to go back into my Y. I'm going to clear out that, and I'm going to clear out that. I'm going to go back up to Y1, and first thing I'm going to put in is a negative because I need the negative. Then I'm going to go to math, and then I'm going to go to num and get an absolute value after it. I'm going to put an x minus 3 inside of the absolute value. I'm going to get out of the absolute value by an arrow over, and I'm going to put a +4. I'm going to put that in, and then I'm going to graph this. Like I said, I don't like putting 2 things in at a time. You're more than welcome to if you like to sort. I'm not into sorting. My graph, like I said, was going to be upside down. So now I'm just going to put second function graph, and I'm going to start plotting some of those points like that. So I'm just going to plot some. It didn't give me a range of data, so I'm just going to use my graph paper. So I see -4, -1, 2, 3. I see -1, 2, 3, down 1, 2. I see -1, -2, down 1, -1, 0, 0, 1, over 1 up 2, over 1, 2 up 1, 2, 3, over 3 up 4, over 4 over 1, 2, 3, 4 down 1, 2, 3 over 5 down 2, 6, 1, and then we're going to arrow on my calculator, and we got 7, 0, and we got 8, negative 1, 9, negative 2, and 10, negative 3. There, I used my paper enough to touch the end. Might have to go over farther here, but you can kind of get the idea that you're going to be like this all the way down, just so you can follow. Okay, so that's the first one. So now I'm going to go to my Y chart. I'm going to get it out, and I'm going to put in the second one. So I don't have a negative, so the first thing I have to do is math, arrow over to num, ab, and I'm going to put 0.5x, and then I have to arrow out of it to minus the 5, and then I'm going to graph. Like I said before, this vector is going to be upward. It's very narrow one. It's very tight. And then we talk about how they get wide and all this stuff. So now I'm going to put, I got that in as my graph. So I'm going to go second function table. And now I'm going to actually graph some of the points that are on my calculator. Now there's a lot of halves points on this. I'm not plotting those. 0, negative 5 is my first whole one. Then I'm going to find the 2, and it goes down to negative 4. And what I mean by that is there's a 1 down to a 4.5. There's a 3 down to a 3.5, but I'm not doing those. We can go over to the 4 and then down to the 1, 2, 3. And then we have over to the 6, down to the 2, and then over to the 8, 5, 6, 7, 8, to the 1. Ooh, we have a match, so I'm just going to jot that down because I might need it. And then I have a 10, so I have an 8, that, and I have a 10, 0. All right, so now I got to go the other way because I only have one side of a vector. Usually if there's one, there's probably going to be a meet over there somewhere. So I have a negative 2, negative 1, negative 2, negative 1, 2, 3, 4. So I'm starting to go this way. I got a negative 4. 1, 2, 3, 4, down 1, 2, 3. So I have that. So I have another meet. I have a negative 4, negative 3. And then I have a negative 6, 1, 2. I have a negative 5, 6, 7, 8. I have an 8, negative 1. And there's my other vector. And then I can go more if I want to have a negative 10, 0. And then they want your meeting points. Okay, so we drew that. That's our meeting point. So from the graph, we see that there are two intersections. There's negative 4, negative 3, and then there's 8, negative 1. So those are the first things that we fill in there. Now, as we move this up a little bit, it says the fact that the graph of the function meets at these 2 points means that when x is a negative 4, both f of x and g of x are at a negative 3, or when x is at an 8, the g of x would be at a negative 1. Okay, and the reason why we know that is because f of x and g of x, if we look at that as the graphs, this is where they're meeting up. Okay, so it says x is negative 4 when x is 8. Therefore, the solution of the original would be the two numbers we need. The solution sets would be negative 4 and 8 are our x values. So a positive 8. So like this is an x value, and there's an x value. Okay, so that's kind of what this is all talking about. Okay. All right, so the last piece, it says, let's write two functions. So we see this and we see this. So let's say f of x equals negative absolute value x minus 3.5 absolute value plus 4. And then we can say g of x equals negative 0.25x minus 1. I hope you guys all recall this right here. This is going to be a line because there's no power to the x. It's just a single x, and that's like y equals mx plus b format, which is slope. Okay, so we're going to enter these into our calculator, and we're going to draw. Okay, now this is going to show you that this graph, see how we have like a quarter, we have like a decimal going on here. That means somewhere along the way we're not going to have a whole number set of points, so we still have to look for the common meeting point, and sometimes that's harder to find in the x values in the graphing calculator. So the first thing we're going to do is we're going to put that other formula in. But what we got to do is, let me get to the y and let's clear that out. All right, so we have a negative going on. Then I need the math, the num, absolute value, and I'm going to put in an x minus a 3.5, and then I have to get out of the absolute value and add a 4. Then I know I have this one right. I go to graph. It's going to be an upside down vector because it starts with a negative sign. It starts with a negative, it's going to point downward. It's just like a parabola is going downhill. All right, so now we got to plot that. So second function table, and it's ugly. It's all on halves. So this one's just yucky at many levels. So it's 0, a half, and negative 1, down a half, negative 2, down 1.5, negative 3, down 1, 2.5. Now we can go the other way. I mean, we can keep going down. We have negative 4, down to 3.5, negative 5, down 1, 2, 3, 4.5. Hopefully we have meeting points before that, just so we don't have to plot anymore. So then we have a 1 at 1.5. We have 2 at 1, 2.5. We have 3 at 1, 2, 3.5. We have 4 at 1, 2, 3.5, which is crazy. For some reason we have a stutter step there. But then we have 5. We go back down to 1, 2.5. So that's kind of like our vector range right there. It's kind of weird. It's almost like a little platform, but it's there. And then we have 6, 1.5, 7 at a 0.5, and there's our little marking, and we can kind of just go like that. All right, so then that's that one. We're going to clear that out, and now I'm going to type in the other one, which is just negative 0.25 x minus 1 graph, and this is a line. Okay, wrong button. Second function graph. All right, so now we got some yucky ones again. So we got 0, negative 1. We have a 4 at a 1, negative 2. And we got a 2, a negative 2, at a 0.5. A 2 at a 0.5. I made that one too small. A 0 at a negative 1. This is very, very close. It looks like we're going to have, a 2, positive 2, we got a -2. Did I type in something wrong into this calculator? Let me check. Negative. Oh, that's why. Oh. 0.25. I didn't need a negative there. Delete that out. Graph that. All right. Well, good thing I didn't go too far with that. Hey, look at that. We made a mistake. I made a mistake right away. Now I got to plot 0. At least I was smart enough to realize it wasn't making a line. And then we have 4, 0. And then we have -2, -1, -2, down 1.5. Okay, so now we're it's going to go like this. It's really going to be tight. And then, so it looks like we have a match. Determine an intersection point. We have a -2, -1.5 as at least one of our points. And we have a 6 up a 0.5. And we have a 7 up 3/4. So we're meeting, this line is looking really rough for me, but our line's meeting somewhere right here. And that we don't have a true identity of that, but it's got to be at like a 6. It's probably like a 6.8-ish on, like here's 7. It's meeting right about here. So I would say that's a 6.8. And they got to give you a leadway on a New York State regions just in case. And we're not quite up to the 1. So we're not at the 0.5 and we're not to the 1. So I'm going to say a 0.7. And we're going to call that close enough to the other intersection. But normally they just ask you for, is this an intersection point? And then verify if these work. We actually just put them into the equation and see if they work. So for instance, we take our absolute value and then we set it equal to 0.25, and we're plugging in the x value, remember, because these have x's in these equations. And we're seeing if this side will equal this side. So we can actually get out of that, and we get back into normal function calculator, and we're going to go negative. We still have to do math, num, get an absolute value. And we can go -2 minus 3.5, get out of the absolute value, put a +4, and we get an enter. And we get, on this side, we get -1.5 on that. So now we got to put the other stuff in the calculator, 0.25 parentheses, -2 parentheses, -1, enter, and we get a -1.5. So we know that so x equals -2 is correct. So we know that that is that. So then our next, let's check if I'm close with 6.8. So now we do the same thing again. We put a 6.8 in here. And then we do the other side. So negative 0.25x minus 1. All right. Yeah, I did need to use a negative, so that's why I was off a little bit. Well, we'll just go with this, and we'll see if this is correct. So we have that, and we don't need the negative there because it seems like they wrote a negative on our paper, but really we weren't using a negative on our paper. So let's put it in and see what happens. We go negative, and then we got to get the math, num, absolute value, 6.8 minus 3.5, and then we have to get out of the absolute value, put plus 4, and we get 0.7 on this side. So then let's do 0.25 times, right here you put a 6.8, so times 6.8 minus 1, and we get a 0.7. So we have the match on the calculator, 0.7, 0.7, and a negative 1, negative 1. So we are actually okay. But the original problem, that's why I was messing up, is our original problem had a negative in it. But as you can see later on, they didn't give us the graph paper to be able to release that kind of data. So this is what we have. So, all right. Hopefully this all makes a little bit of sense for your homework tonight.